qui est une grande spécialiste de l'acquisition. Elle a commencé sa carrière avec Roger Brown à Harvard, donc auteur d'un classique sur l'acquisition, First Language. Et j'ai publié l'auteur de très nombreux livres et articles. Elle a publié notamment une monographie sur l'acquisition du langage, Language Acquisition, que j'ai dans ma bibliothèque. Et elle s'est intéressée ces dernières années à la théorie des souris, à l'influence des conditions socio-économiques sur le développement cognitif et linguistique des enfants, et bien sûr à des questions d'acquisition du langage. Je lui laisse la parole.
Thank you very much. I'm going to speak in English. I hope I can be understood. Please let me know if there's something you need clarifying. I'm going to go quite quickly, but there's lots of visual support, so I hope it'll be okay. I wanted to address today the more general question of what kind of thought needs language, and I know this has been the content of many of the talks that have been doing exquisitely careful historical exegesis of texts from ancient philosophers and linguists, and I'm coming in as the American barbarian, making reference to very little before about 1940, so apologies to all the historians. So this is my outline. I'm going to talk about a few varieties of contemporary views of language and thought, and I'm going to ask about their status in child development. I'm going to spend a little time on the case of theory of mind, although that is the content of my workshop tomorrow, so I don't want to spend too much time on theory of mind. Instead, I want to ask what could it mean, and in particular, is it one of a set of examples where language, in fact, assists in the development of a concept. And I'm going to talk about these other domains and their implications for infants and for perhaps other species. So I'm going to start very contemporary. Jerry Fodor, with one view of the relationship between language and thought. As you know, he believes that thought requires a format that requires language. Thought for him is propositional in nature, and we need this kind of thinking to reason, to draw inferences, but he argues that it can't be natural language because natural language depends on having language of thought already. You couldn't learn a language if you didn't have a pre-existing language of thought. And also infants and animals have thoughts, and therefore they too have a language of thought that can't be natural human language. And furthermore, it's innate, because learning concepts is impossible. That's a very complex set of beliefs to digest, and not everybody believes them. In particular, does it mean that all these concepts are innate? I tried to represent hegemony, a combustion engine, and a quark, just to give you some examples of things that give trouble to the concept that all concepts are innate. So moving on, let's step back from the brink of Jerry Fodor and ask, however it is that concepts are acquired, and maybe they are innate, but perhaps some of them are learned, it may be that we don't share all our concepts with animals. Perhaps the concepts that are unique to humans are those that require a propositional or linguistic type format, in which case it's a bit redundant to require a language of thought when we already have natural language doing that work. Why not argue that natural human language could do the work of language of thought in Fodor's terms? And several recent philosophers have argued just that. For example, Gabe Siegel, the philosopher Hutto in England, Peter Carruthers in America, and so on. Another possibility arises that language is not needed for most kinds of thought. There's lots of thought that we have, and images and so forth, that animals have, that infants have, that doesn't require natural language in order to think. But perhaps there are certain pieces of our reasoning, particularly those that require integration across separate modules of the brain, if you believe in modularity theory, that we have specialized subsections that deal with things like three-dimensional vision or large number calculation and so forth, perhaps language is needed to serve as a kind of translator or as a bridge between these specialized modules. This is a position that's held by Elizabeth Spelke, the psychologist, and Peter Carruthers has interpreted her as providing a general account of the role of language. So language in this case would assist in cross-modular thought, and that would happen in the course of child development. As language develops, the child would become capable of integrating the outputs of different specialized modules, and as a matter perhaps of language of habit in the adult, that is, language is an easy way to integrate the cross-modular connections. What about linguistic variation? This is something that has worried people. What if different cultures have different semantics? So if different languages have different inventories of semantic contrasts, perhaps we have to learn to think for speaking, to put it in the words of Dan Slobin. For example, if you're a speaker of something like Tibetan, you have to pay attention to the sources of your knowledge, because Tibetan has evidentials, as I'll talk about tomorrow. You have to, every time you make a statement, decide, how do I know this? Is it through my perception? Is it through inference? Is it through being told? We don't have that problem in English. We can lie all the time. But in Tibetan, you have to say what the source of your knowledge is, or indicate it. So in order to speak in Tibetan, you have to kind of see the world through a different lens, if you like, in terms of paying attention to sources of knowledge. Or if you're a speaker of Spanish, you have to pay attention to the direction of motion in a way that English often doesn't. We pay more attention to the manner of motion. We have dozens of verbs for different ways of moving through space, which Spanish tends to put in the adverbial form. So when we come to select a verb in English, we are looking at a different set of possibilities than the speaker of Spanish. So when we speak, we have to think differently, right? But other people have said, well, you know, maybe it's not just in the course of preparing to speak that we have to think differently in different languages. Maybe we are always on the alert that we might be asked to report something in the language, and therefore perhaps we should always be alert in looking at the world. In case we're asked to describe something, we'd better be paying attention to different categories. And I've called this a slippery slope because, of course, what it ends up in is the position of Benjamin Lee Wolfe and Sekier and other linguistic determinists, as they're called, from earlier in the last century, the darling of the humanities. That is, every linguistics language professor that I've ever heard justify the reasons for learning another language is that you come to see the world in a different way. So everybody loves the idea of Benjamin Lee Wolfe, the idea that habitual ways of speaking lead to habitual ways of thinking, and we categorize the world differently depending on our culture and our language, and there is no such thing as objective reality in the extreme form. We see the world through the lens of the language that we speak. I call it the slippery slope because he may be the darling of the humanities, but he's the nemesis of many people in the hard sciences who disagree that there are significant effects of language on thought. So let's turn then, having given you a broad overview of different positions, broad positions on the relationship between language and thought, let's look at some empirical evidence from developmental psychology about whether language has an influence on major categories of concepts. And there's been a lot of recent work in infancy and early development, testing in new ways what kinds of things infants know. And these have concerned very basic ideas such as object identity. When does a child know what an object is? Or number. When do they understand number? When do they understand basic principles of causation? When do they understand space and how to find something through navigation? When do they understand the concept of another's agency or intention? Are these concepts acquired without any assistance from language? Many of them seem to be things that animals ought to know about too, so it seems a little implausible that language would provide any assist. But in each case, I can show you that there is something that language does in each of these domains. So let's think about object identity. I'm calling it by the philosophical term of a sortal for good reasons, and it took me a long time to understand the difference here. But a sortal concept provides evidence not just of what counts perceptually as, let's say, a dog. This class of things in the world has the right visual properties to count as a dog, but also where a dog begins and ends. What are the edges? What distinguishes its edge from the next thing? How one counts them. Are they all just en masse dogginess, or are they discrete entities, right? Whether the example can change and still be the same individual. So, for example, when my puppy grows up, I don't, come down one morning a year later and say, oh my God, that's not the same dog. In fact, it's just grown. But think about it, we have to understand this for every particular object that we learn about. A flower doesn't change identity when it grows from a seed to a seedling to a plant to a full flower and then flops over, right? It's the same thing. A hand can be in all kinds of different configurations and still my hand. A chair, on the other hand, should not grow overnight, otherwise we're in a Alice in Wonderland world. A cloud can transform, a pile of sand can transform. So for every kind of object in the world, you have to know something special about its properties, whether they're allowed to transform, under what conditions, and so forth. That's what sortal knowledge is. And there's been some fascinating work done in this domain by an ex-student of mine, Fei Zhu, and also by Jean Mandler, who agree that infants below the age of about 10 months may only know general sortals, such as physical object, or living being, or artifact. They may have broad classes within which they do not distinguish their properties. So, for example, now I need a screen. If I should have thought about props, I never do. Suppose I show you this coming out this side of the screen, right? And then I show you this coming out this side of the screen. You all would draw the conclusion that there are two objects behind the screen, because you know this cannot transform into this, right? But the infant up till 11 months of age is fully happy with one object appearing behind the screen when you finally lower the screen, because all they know is sortal, sortal, a sortal is behind the screen, right? It's a very peculiar result, but it's been found over and over again. It's only at about 11 or 12 months, oops, touched something by mistake now. It's only at about 11 or 12 months, coincident with the acquisition of real words for the things in question, that the child begins to correctly anticipate how many objects are behind the screen in such a case. That is, they're developing sortal concepts such as bag, truck, cup, just as they're developing the understanding of those words. So, maybe it's possible that language paves the way for particular sortals. And this remains a very open question about, for example, what monkeys can do in similar circumstances. Let's think about numbers. Infants can do arithmetic operations with small numbers, less than 4, and judge ratios with large quantities. So, for example, they can tell the difference between a small pile of sand and a large pile of sand, or they can tell the difference between 1 and 3 objects when they're in front of them visually. But they can't do it with large numbers. In fact, as soon as you get to 4, they begin to break down, so they can't tell the difference between 4 and 6, for example. It's Spelke and Carey, who've done classic work on this, argue that learning to count in language, the counting sequence, 1, 2, 3, 4, etc., is the crucial bridge for children to acquire the successor function, which is what you need in order to understand that each number is one bigger than the one before, and that's how you judge the quantity of numbers that you can't keep in this very elementary number tracking system that you have that only allows you to track up to 4, which we share with monkeys. Okay, so once they achieve the correspondence of 1 means 1, and 2 means 2, 3 means 2, they're called 1 knowers, and 2 knowers, and 3 knowers, then they begin to take off and understand that all numbers have a corresponding quantity. Yeah, if it's an experiment, if you have access to small children, you can test them. You can say, for example, can you give me 1 penny? Can you give me 5 pennies? And when it gets above their number that they know, they just take a whole handful and give you them. Right? So they don't understand. It's just more than a number that they know. Okay, causation. Surely understanding causation is foundational to all species. How could we operate in the world if we didn't understand causal relations? And indeed, infants are surprised by events that apparently break the rules of ordinary physics. So if you push an object off a stage and it just stays in the air because of miraculous hidden strings, one hopes, then infants show shock and horror. But there's still something more to learn, and that is that one can intervene in a causal event and show the relationship between cause and effect. Tomasello made this remark several years ago, and it's now been tested in children by Bonowitz and her colleagues. That is, if you show, let's say, a chimpanzee, a tree waving in the wind, and the tree is dropping fruit on the ground, the chimpanzees will indeed hover around the tree and gather up the fruit, but no chimpanzee shakes the tree. Okay? They don't necessarily understand that they can causally intervene to make the tree shake and produce the fruit. And the same thing seems to be true of young children. Young children expect certain events to happen when they see them habitually happen, but when they fail to happen, they don't understand that they can reach in and cause it themselves. And interestingly, language seems to serve the bridge. When they understand a sentence like, you make it go, that's when they intervene and do it. And before that, they sit and expect things but don't do them. Actions. It's a very difficult domain. How do you understand the concept of a verb, the concept of something that is, you know, not like a thing? It changes according to who's doing it. So running is supposed to be the same verb, whether it's a dog or a person or a baby or whatever, and yet the action is in fact quite a bit different. Agents change, and it's still an event of running. In fact, infants at 10 months are forming expectations about what are sensible events. So they understand the difference between events like giving and hugging. This is a very clever work by Peter Gordon, in which he showed infants events in which there was an extra object. In the case of give, of course, it was a necessary object for the act of giving. So he showed person A giving a teddy bear to person B. And in the hugging event, person A is holding the teddy bear while they hug person B. And then he shows a new video, that's what's shown at the bottom here, in which the teddy bear has disappeared from the scene. So the person still gives the giving motion, but there's no teddy bear there. Or the person still does the hugging, but there's no teddy bear there. And infants at 10 months are bewildered by the giving event that doesn't include a teddy bear, but are not at all upset by the hugging event that doesn't involve the extraneous teddy bear. So they know what's extraneous and what isn't to an event prior to language. But nevertheless, even at 2, children are disturbed by a change in the actor, a change in the agent. They have difficulty keeping track of whether a verb is the same if the agent changes. And this is enormously helped by having the verb in question. So there's an intimate connection between learning verbs and being able to keep in memory what the action was independent of the agent that's doing it. Space is another area that Elizabeth Spelke has used as her seminal example of why language might be the bridge between two modalities, modules, I should say. So she has a rectangular room with boxes in the corners into which you can hide things. And imagine this with no clues, no blue wall or anything. If you hide a food object, let's say, in one of the corners, and then you make the animal or the person dizzy by spinning them around, put them back in the space, they can navigate to the corner, but they make mistakes by going to the geometric equivalent in the other corner. So they know that it's one of these kind of corners, but there are two of them. And so they go to one corner or another if they're dizzy. And yet, so they've got geometric ability, and rats and infants and young children also have landmark ability. So if you put, for example, I don't know, a decorative piece on the place where the thing was hidden, they can easily find their way back to the landmark. So they can do geometric reasoning about navigation, and they can do landmark reasoning about navigation. The advantage that comes in at around age 4 in children is that if you hide something in that corner and you have a blue wall, then we as adults can remember something like it's to the left of the blue wall. That is, you're using both the landmark information and the geometric information, and you no longer go to the opposite corner when you're dizzy. Whereas rats and children younger than age 4 who don't have the language capacity yet to encode something like to the left of the blue wall still end up piling up in the two corners. Guesses pile up in the two corners, I should say. So as adults, we can use language to integrate the information from landmark information and from geometric information in the domain of space. If adults, and this is a preview of something I'm going to say later, so I'll take my time and say this now. Spelke was the first to use shadowing with adults to test the hypothesis that the language faculty is critical for integrating this information. What she did was, not only did she put adults in this room and then spin them around to make them dizzy, but she also had them listening to a message that was coming in headphones, and they had to shadow or repeat exactly what was coming in the headphones. So they were listening to a story, perhaps, you know, once upon a time there was a wicked queen or something like that, coming in, and they had to say it. As soon as they heard it, they had to say it. Once upon a time there was a wicked queen. So their language faculty is tied up. Okay? In that condition, adults cannot find their way to the point with the left of the blue wall because they haven't got access to their language faculty. Now you might say, oh, come on, you know, that's hard. That's just hard. Stop making it so hard. In the other condition, the adults listened to a rhythmic tapping, and they had to repeat it. It's actually much harder than shadowing language, trust me. But you match the two tasks in terms of attentional ability. When people are tapping, they can easily find their way to the blue wall. So it's not just attention that's getting in the way, it's something about language. So keep that in mind, because I'm going to exploit that fact later in the talk. So let me turn to this question of agency and intention and beliefs. I want to spend a little time talking about theory of mind development in infants and children. I'm going to go into much more detail in this in my workshop tomorrow, so I'm trying to condense this to just the critical point about language. What I mean by theory of mind, and what people have meant by it for half a century almost, refers to the folk psychological theory that we use to predict and explain other people's behavior. Of course, this was something that in the era of behaviorism was completely disallowed. Talk of things like beliefs and desires and attention and memory, those were all not terms, mentalistic terms that were regarded as ghosts in the machine, to use a famous expression. But in the cognitive revolution, it became respectable again to talk about these as mental states. It so happens that in many instances there is a difference between a stimulus and a response that is only explained by the intermediate state of mental state that the person has in the middle, namely the way they interpreted the world, never mind the way the world was. So I'll just give you one example. I hope this plays. Yeah. You all don't believe mine. You all have a theory of mine because of the anticipatory giggling that I heard. So when you ask young children the question, why did the girl drink the flowers? 3-year-olds say, wasn't she silly? You know, that she likes flowers, or I don't know, right? But 4-year-olds say, she didn't know her Coke was moved. She thought it was her drink. She didn't see her move it, right? So they immediately understand that she had a mental state that caused her action. But the 3-year-olds are bewildering in their responses. Here's another classic test of false belief understanding. This is the so-called unseen displacement task, where there are two characters, Sally and Anne. Sally puts her, I don't know what it is, ball or something in a basket and leaves the scene, and Anne takes the ball and puts it in the other container. And when Sally then comes back, the question is, where will she look for her ball? And 3-year-olds say she'll look in the box, that's where it is. And 4-year-olds say, haha, she's going to look in the basket because that's where she put it. So big change. They expect that Sally has different knowledge than they do at the age of 4 or 5. Here's another classic test, the Smarties task. You have Smarties in France? It's very hard to translate this in America because Smarties are totally different things. But anyway, you understand. So what do you think is in this box? And then the child says, Smarties, and looks very excited. And then you open it up, and unfortunately it's a pencil. And you say, look at that. And you put it back in the box, and you say, before, what did you think was in the box? And the 3-year-old says, a pencil. Failing to remember that a minute ago they said Smarties. And 4 and 5-year-olds say Smarties, and I was wrong, right? And the other question about others' belief is, if I show this to your friend, what will they think is in the box? And again, a 3-year-old will think that friend has X-ray vision, and will say, pencil. We used to say, we learned a lot in the process of doing this task, we used to say, who is your best friend? And then we would choose that child, and we'd say, what if Jane comes in? What will she think is in the box? But my good friend Bart Hollebrands, who was going to be here but couldn't make it, he made the mistake of going to a little Christian school near us, and he asked the child the question, who is your best friend? And the child said, Jesus. And this became then very difficult because what would Jesus think is in the box? It's a very deep theological question. He shouldn't make any mistakes, right? So anyway, we stopped asking that question just as a precaution. All right. So let's take a look at the possible roles of language in theory of mind development. On one view, this whole development depends on what's called executive function development, the ability to defer responses, to resist impulses, and so forth. I'll talk much more about that tomorrow, as will Stephanie Dorelman Tame. But The executive function view would see language as useful only in providing a kind of regulator of impulse towards a response. The theory, so-called, that children are like small scientists trying to make sense of the world, and they eventually graduate from being behaviorists to being cognitivists. They undergo a kind of philosophical shift in terms of their sophistication. That theory would say that language is a useful source of evidence for the theory. That is, you hear people talking about other people's mistakes and false beliefs and so forth. The cultural theory says, maybe there are variations. Maybe not every culture, in fact, invokes the notion of a mental state. But in our culture, we do, and we hear people discussing other people's beliefs and knowledge and so forth, and therefore language provides critical evidence of the content of the theory. Or, and the most radical, and the one that I'm associated with, is that language is needed to represent the belief in reasoning. So, think about the false belief involved in the girl flowers case. We have to represent that event to ourselves, we must obviously mark it as who is the believer, who is involved. There were two characters in the story, we have to distinguish them. One had the false belief, one did not. We have to understand that the state of mind was one of belief, not knowledge, not pretense, not desire. We have to understand that there was a certain content to her belief. That is, that she was picking up her drink. That was the content of her belief that made her reach out and do that. We have to also recognize that it was a false belief and yet motivated her action. So we don't just write it off as she was wrong. We have to know why then did she pick it up. Not that she was just wrong and therefore we should ignore everything she does. We need to predict and explain what she's doing. So to represent propositional attitudes requires a medium that is just as rich. This is kind of an echo of the Jerry Fodor argument, only made particular in the case of beliefs, namely that can capture all the properties of belief states. It's no good just having an image of a false belief, because images, as we know, can't represent falsity or negation. It's no good just having a word like she was deluded, right? Because saying she was deluded doesn't allow you a prediction. You have to know the content of her delusion that made her pick up the drink. They're not specific enough to capture the content of thoughts. But a full language is just right. Sounds like Goldilocks and the Three Bears. This one isn't enough, this one isn't enough, but this one is just right. It can capture falsity, it can capture the content, it can capture who is the believer, and so forth. Now, I've argued that it's not just any language skill that will fit here. So many studies find a relationship between general language skills and success on false belief tasks. Understandably, the child gets both as they get older. They get more vocabulary, they get higher verbal mental age on IQ tests and so forth. But the point is that complementation is the ideal representational medium for these beliefs. And that's why I've pursued the relationship with complements. So this is a kind of task that we've used. We show the child a picture like this, and we say, look, the girl said she found $1 on the ground, but it was just a piece of paper. What did she say she found? 3-year-olds say, a piece of paper. That sounds familiar, right? And 4-year-olds say, $1, but she was wrong. So it's very similar to the false belief task. I mean, this is verbs of communication. We've never, said anything about a false belief. It's just understanding a sentence. What you have to do to understand that sentence is understand that the question applies to both verbs. It's an embedded structure. It's not enough to answer what did she find, and neither is it enough to answer what did she say. You have to say what did she say she found, okay? And that seems to be a critical index of whether the child understands two worlds, if you like, the world of reality that we know and share. Of course, I'm sure there are people out there who don't believe in a real world, but let me be naive enough to suppose it, and then a world in somebody else's head that doesn't correspond to the world you share. So, in terms of main findings of the developmental literature, longitudinal work following children over time supports this causal direction that when the child gets the ability to understand those complement structures, that's when they can understand false belief tasks. We don't get false belief reasoning without them. Now tomorrow I'm going to go into a long discourse about the latest research on infant false belief reasoning, which offers something of a contradiction to the story that I'm telling. And what you'll see is there's lots of other reasons why infants might be behaving the way they are. I'm going to assume for now that explicit decision-making false belief tasks only come in at 4, and the predictor of them is complements. We recently did a very large longitudinal study looking at a whole group of children, actually all of them growing up in poverty in Texas and Florida, and we looked at different causal factors to explain when they achieved false belief understanding, and the strongest immediate predictor of how they did was understanding the syntax of complement sentences. Training studies have been done in which if you train the language of complements, it pays off in the child's improved performance on false belief tasks. Research with deaf individuals who are delayed in language, not any deaf individual, but those deaf individuals who have significant language delays, they have problems in false belief reasoning concomitant with their understanding of complements. Executive function, however, is not delayed in those same deaf children. So in terms of splitting out the contribution, it's more that Stephanie will talk about tomorrow. It looks as if complements are at least as important. So what are the alternatives? Could it be that the child is learning to think for speaking? Is it a kind of verbal scratch pad that they can take notes on that is helping them achieve this? Is it language serving as the means of thought in this particular instance, that they are somehow thinking verbally about the situation in order to give a response? Is it the language faculty that's getting engaged? So I'm going to tell you about a series of experiments we did with adults as a way of easing into the second piece of this. How am I doing on time, by the way?
You have 20 minutes.
20 minutes, I should just make it. Okay. So let me just briefly tell you about this work I did several years ago with a student, Ashley Newton, for the thesis. We were inspired by the work of Elizabeth Spelke with the rectangular room with the shadowing task, tying up the language faculty, and we thought, what would happen to adults if they had their language tied up in echoing or shadowing speech, and would they then fail to understand a false belief scenario? This provided us with a way of asking, is it just in development that you need this language in order to succeed? Once you've got it, do you then not rely on language? You do it automatically? Or do you still need language to figure these situations out? So we showed them videos, silent videos. We had people actually dressed up as mice and rabbits. It was a favorite experiment of the students. And the situation was as follows. A mouse, it's very much the change of location task, like Sally and Anne, only it's a mouse and a cat. So the mouse leaves his cheese in the box C and then goes back into his hole, and then a wicked cat comes and moves the cheese. He fiddles about at B. We wanted to sort of activate all these different locations. He fiddles about with B and then changes his mind and leaves it at A, and then he leaves, and then we ask the question, where will the mouse look for its cheese? And the way we ask the question is by giving the people two choices of ending of the video. The mouse comes out of his hole and goes to C, or the mouse comes out of his hole and goes to A. And then all they have to do is choose the right ending of the video. So it's entirely non-verbal. They have to tap on the right ending of the two videos. Here's the true belief case. It's exactly the same, except the rabbit in this case, actually they will counterbalance, but let's keep it this way. The rabbit leaves his carrots at A, and then goes not back into his hole, but sitting right there watching while the cat moves the thing around. And then we again ask, where will the, in this case, rabbit look for his carrot? Okay? So it's a true belief case because there's no false belief involved. The rabbit saw what happened. All right. So I'll show you the results and then I'll show you some graphs. When you tie up the language by having people shadow verbal material coming in their headphones, they can no longer choose what the right ending of the video is. They do the same thing for true and false, they're just random. It's not just attention, because we did the same control as Elizabeth Spelke. That is, we gave them a rhythmic tapping task, and in the rhythmic tapping task, it didn't disrupt false belief reasoning. It isn't, as Tom Roper argued with me, he said, well, how can you keep track of two stories at once? You're trying to keep track of the story coming in your ears, and you're trying to keep track of the story out in front of you. You can't possibly keep track of two stories. I was a little doubtful about that explanation, because if you've ever been in a shadowing experiment, you're not taking it in very deeply. You're not really following what you're saying. You're just echoing. But nevertheless, I did a control. I had adults shadow Swahili, which none of them knew. So it's sounds coming in that are language. I mean, it sounds very verbal, but you just don't know what you're saying. You don't know what you're saying. And there's no story there at all for the adults. But it disrupts to the same degree as English, because it is tying up the language faculty. Adults are not particularly conscious of what they're doing. You say, why did you choose that ending? I don't know, it felt right. They don't talk about the reasoning in their head. So whatever's happening is a pretty unconscious process. Here's the control for attentional demands. This is the red one, is what happens if you give them verbal shadowing. This is what happens if you give them rhythmic shadowing, the blue. So you can see the big difference in the false belief case only, no difference in the true belief case. In the case of Swahili versus English, identical results. So, what does it mean? Well, it may be that language is the best medium in which to represent beliefs, especially false beliefs, but of course that's not persuasive to many people. There have been many, many arguments about this. In particular, the rhythmic control is considered by some a very weak control. Perhaps there's still something more demanding about language coming in the ears than about rhythm coming in the ears, even though I had a matched task on which they were made equivalent, and even though nobody raised that about this Spelke's work, never mind. The point is that there's something not quite adequate about the control. So, of course, there are other people who deny that anything is represented in the mind at all. So, connectionists, whatever, people who have a connectionist view don't necessarily want to argue for any kind of symbolic or propositional representation. But I'm ignoring those. So let me finish by telling you about a novel methodology that I've made up that promises to explore other aspects of concepts that adults might or might not be able to get under the conditions of shadowing. So I tried to ask, what kind of concepts can an adult form in an implicit concept formation task? That is, they're not told to do anything except watch a screen. It's an eye tracker. And I just watch what happens to their eye gaze. So they're oblivious about there being any task involved at all. What they see is two stimuli on the screen, two pictures. And after 3 seconds, 5 seconds, one of them animates, turns into a moving picture. And there is a rule about which one will animate over the series of pictures. The question is, can adults pick up the rule so that they look in anticipation at the one that will animate? What kind of rules can adults do, and what kind of rules can they not do? when they're just looking, or when they're looking and shadowing, tying up the language factor. So that's what kind of concepts mean language. Here are some results. I started out with a very simple idea, maybe a simple proposition, a simple transitive sentence like, mother kiss baby, which after all is not true of a single instance in the world, but is true of an infinity of possible instances in which a mother kisses a baby. That's the nature of sentences, that they are about a set of eventualities, not just one instance, right? What allows us to see the similarity across events of mothers kissing babies? Not just mothers, not just kissing, but mothers kissing babies, right? So I asked the people in the local daycare center to come into a big kiss-in, and I had them kiss their babies, and I filmed it, and I had the babies kiss the mothers, and I filmed it. And so I had pairs of pictures with mothers kissing babies and babies kissing mothers, and I put them in this pair of screens, and you watched the pair of pictures, and then after a moment I animated one of them. And the one that I animated was where the mother was kissing the baby, not where the baby was kissing the mother. So you look at these two pictures, they're very similar. I think, in fact, the mothers and babies are not the same in the two pictures. The first few are the same, but after the first 8 training trials, they actually changed to different mothers and babies in the two pictures. But still, the rule is the mother's going to kiss the baby. Right? Can you learn that? Turns out, trivially, if you're not shadowing. If you're shadowing, you can't pick it up. Whoa, that's so fundamental. That's just such a fundamental idea. That's something that's a simple transitive proposition you can't do if you don't have your language faculty. Okay, so I've done this again, twice, and it happened again with Monster Chased Dog. So I made cartoon characters, I made them very simplistic. I had either the monster chase the dog or the dog chase the monster, took all the emotional stuff out of it, tried it again with these very straightforward stimuli, same thing happened. Okay? You can do it if you're not shadowing easily. You can't do it at all if you're shadowing. So then, very interesting case, my student Anne Nordmeyer, who's just graduating from Stanford now, she decided to look at the idea of propositionality par excellence, namely negation, which we know images can't do, right? So how on earth are we going to make pictures of them? She wanted to know, could adults pick up that it was always the negative one that animated, not the positive one that animated? So let me show you what I mean. Here are some examples of negation where we have paired examples.